Hello and welcome to today's webinar, A Better Architecture for Hybrid WAN. Covering this topic today is Steve Wu, VP of Product and co-founder here at VeloCloud. First, a couple of administrative items. We are recording the session, and you'll get a link to the recording shortly after the event. Also, I've uploaded the presentation slides in the attachments and links section. Also put a couple of other resources there. We do have time at the end for Q&A, but send your questions in throughout the presentation. And now, welcome Steve.
Thanks, Sasha. So welcome. This is our second in a series of webinars on SD-WAN architectures. Last time we did an overview of the different historical and SD-WAN architectural approaches. And today we'll do more of a deep dive and really focus on how SD-WAN is applied to and improves hybrid networks. So let's start with a definition of what is a hybrid network, right? So it's basically a combination of two or more different types of networks. However, in our WAN context, I think it typically refers to or understanding that it's a combination of a private and public WAN transport. So basically, in a lot of cases, a T1 circuit into an MPLS service, and with the addition of broadband internet transports. So in today's webinar, I really want us to challenge this definition. I think, first of all, the bar to be a hybrid network is way too low. All right, so we'll cover what this is and what it's lacking. So while it's definitely a step up from a purely private network, I think there's lots of room for improvement, and that's what SD-WAN can do for a hybrid network. And then secondly, and actually looking more broadly, this definition, I think, is too limited by just looking at the transport, which is only one aspect of the wide area network. So we'll look at expanding the definition of the hybrid network. So in the first section, let's actually focus on the transport. Actually, let's look at what the tiers of hybrid transport are. Right, so from the historical perspective, up through to where we believe it should strive to be, both with SD-WAN and also advanced SD-WAN services. So as I said, the bar is pretty low, so it's a pretty easy hurdle to jump over. All right, so hybrid WAN is simply, as I mentioned before, one that uses both a public and a private circuit. But in effect and historically, these could actually be totally disparate networks. That's how often do you see, and I've seen private networks for corporate traffic, point of sales, and then a totally separate broadband circuit that's reserved just for corporate web browsing, or maybe even just reserved for guest or client Wi-Fi. I've also seen cases where you have multiple private circuits, so it's a hybrid of different private circuits, but each circuit individually is actually allocated for a different application, and actually requires manual readdressing of servers to shift application traffic from one private network to another. And some of this is due to the addresses assigned by each provider. So these are the two, I think, the low bars in terms of, yeah, we have hybrid WAN, but it's disparate networks. Or in the other case is if the traffic can leverage more than one circuit automatically, the use of the second circuit, and typically the internet circuit, is used only as backup for failover from the primary, which means there's another circuit bandwidth service cost that really is going unused. So, and a lot of our enterprise customers recognize this, which is why the huge interest in seeing how we can apply SD-WAN to improve the state of the traditional hybrid WAN. So I think the first goal to raise the bar, and it's good progress, but halfway to, I think, the ultimate goal is that we can unify and simplify the usage of all the available links. Right, so it does this by using business-based policies, enterprise-wide orchestration. Right, so to basically combine those disparate networks, use them in an active fashion as opposed to for backup only. But what we see actually at this first raised bar is that ultimately critical traffic still relies on the private network with its SLA offering. So even though we've added internet because it's the internet addition to the hybrid WAN is a best effort circuit, the policies that people stick to at this level is basically pinning the critical traffic and the network sensitive traffic to the private link. Or if we go a bit further and allow additional traffic to use and actually leverage the internet, so allow some more of the actual business applications to leverage the internet, the best practice is still always to have a private circuit to steer back to, and it makes sense because the internet unconditioned is really a best effort, so you always want to have the backup for the broadband circuit being going back to the private link. But then if you actually start the corporate traffic on the broadband internet circuit, if you have to steer it back, session continuity is not guaranteed, so it sort of still fail back to the private circuit. That's sort of the middle state of the ground. So in the next slide, I actually want to suggest that we should shoot for the ability of saying the stars, but more appropriately to our use case, and you'll see it later. And in this photo, let's shoot for the clouds. And the goal is to not just simplify the hybrid WAN, right, but we actually want to optimize the performance for any transport. We actually want to add these additional circuits, add the public transport to this hybrid WAN bundle, but make the performance of the apps across any of these links truly transport independent. So the goal is that even the most critical network sensitive applications can really leverage the bandwidth resources, or actually all the bandwidth and all the resources of all the links, public and private, that we combine into this hybrid network. So let me give an example of what the policies or usage of links would look like, in sort of the simplified and then versus true transport independence. So the example on the left is actually a real-world case study. This was presented actually at the last WAN summit in New York City. I suspect too often this is actually what users are selling for, short of actually having true transport independence. And this was presented by a fairly large enterprise customer. So the three rows basically see that priority site-to-site traffic, so corporate traffic going from a branch back to the headquarters or the data center, is strictly assigned or limited to the private circuit. And then only what they call normal traffic or less important site-to-site traffic can start to use the internet, but then this traffic is simply load balanced between the private as well as the public capacity. And then very interestingly, the cloud traffic on the bottom uses the internet because it's going to the cloud, but actually no distinction is given to the priority of the traffic. That's because none can actually be provided on best effort internet, but this actually overlooks the fact that as corporations move towards applications in the cloud, the actual cloud apps and the cloud infrastructure as a service or private apps hosted in the cloud are actually high priority applications. So don't I want to treat it as high priority? So we'll see later, and this is getting a bit ahead of where we are now, but with a cloud deployed SD-WAN solution by service providers, you can actually extend private lines and therefore full hybrid actually to cloud destinations as well. So, but anyway, on the left-hand side is the state of using SD-WAN to simplify the use of a hybrid network, but really want to get to the right-hand side. So if we can deploy advanced SD-WAN, and I'm just showing the goal and the policies to deliver true transport independence, the policies on the right-hand side are actually much simpler. So it's saying we have both site-to-site traffic as well as cloud traffic. In either category, we want to be able to define them as priority or normal. And on the right-hand side, let some underlying technology automatically decide which resource to use and automatically put that traffic on the appropriate link based on the priority of the traffic, the links available, and the performance of the links, and to do this for both corporate destined traffic as well as traffic to the cloud. All right, so basically we're suggesting that this manual static policy assignment, specific link on the left, not to do that to try to manually tune or optimize performance. We want performance really to be automatically achieved. So another simpler view of this, and I'll show this as a background to later when I'll show when we do want to have link policies, but the goal in terms of SD-WAN solution being able to set this would be very simply for application traffic, define all transport as available for that traffic and let the system automatically decide, right, based on the business priority for the application-specific requirement of the network in terms of capacity, jitter, latency, and packet loss, as well as the real-time link conditions, automatically figure out which link to steer each application onto, and not have that set as a static policy. And then, in fact, on a per-packet basis, re-steer a session mid-flow if changing link conditions require this. This is the goal in terms of, at the policy level, what would be a great, very simple way to set the policy in an SD-WAN solution. Next slide, I'll look at, so what's the technology that can actually enable, I think, such an ideal, simplified policy for use of circuits in a hybrid WAN. So we said SD-WAN can certainly simplify the use of a hybrid network. Just coining sort of an advanced SD-WAN capability for hybrid, right? And this is to really enable that automatically assured performance and simplified automatic policy. And basically, what we need for this is three critical functions, shown on the right-hand side. So first, and then I'll cover the use case example on the left-hand side. But on the right-hand side, the three critical functions. First, we want to automatically and continuously profile all the links in terms of capacity and performance that you add into the overlay, especially as certain types of shared broadband links may have congestion as load changes on the shared resource. Then, based on this link performance, right, well, we want to steer critical apps to the best link. The extension is you can do it on a per flow basis, and the ultimate goal is to do this on a per packet basis, not flow, so that we can actually move a session, for example, a phone call, actually move it midstream without dropping the session, without the user having to redial, and without the user even noticing a glitch on his sensitive business critical voice or video conference. Having a per packet capability also allows us to split a single high balance session across multiple links to offer the application the combined capacity of all the links and actually deliver faster application performance. And then the third key element, which is also needed in addition to the path of link steering, is that, say you only have a single link available, or actually one of the links has failed, or both links have degradation at the same time. Basically, that would remove your ability to steer around the problem. So then what you want is on-demand remediation technologies, right, to fix packet loss, to fix jitter. So that these technologies would include error correction, packet replication, jitter buffering, fast local retransmission of TCP session packet losses, and all this is the goal of all this to get the end benefit of not having to depend on the SLA guaranteed quality of a private link to assure the app. You can get this across any of the links, so now I can actually use all the links. And so actually this fixes the degradation that people assume might be present in the broadband circuit that they've added to the hybrid, which is why in the past people have used static policy to keep the critical traffic just on the private portion of the hybrid network. On the left-hand side, the quick GUI snippet of how this might work in real life. You might have two underlying links. The top shows the desired result of applying an advanced SD-WAN technology. In this case, you might have a degradation, then an outage detected on the top underlying link. You might then want to steer traffic dynamically in the middle of the flow to the second link, as you can see on a lot of the broadband links. Because it is a shared best effort link, you might have congestion that might cause packet loss, say when the kids come home from school. So that's when you want to apply the on-demand remediation, and the end result at the very top of an SD-WAN overlay is great app performance. That's the ultimate goal. So as I said, the goal is to let the SD-WAN system automatically assure performance by selecting what link to use for the application. But there are cases where we do want to have policy-based link steering, and I consider these overrides. But this would be for compliance and circuit usage and cost reasons, but not to have to do this to tune app performance. So here's a couple of examples. SD-WAN business level policies can help with. For example, in the first one, if you do a match for PCI traffic, you might want to say, okay, you make this mandatory to go across the private circuit, because the private circuit was assessed to be PCI compliant. So in this case, it's pinned to that. If the private circuit were to fail, you would not move that traffic over to a non-compliant provider circuit. The second example is using an available type policy that says you prefer an application. So in this example might be prefer an application to use the public wired, and this is for cost reasons. As long as it's available, you're not really concerned about the performance for some of these applications. But if that link were to fail, then it is okay to automatically move it over to the public wireless circuit. And then additional enhancement on that is then keep track of the usage of the wireless circuit as well as an extended policy. And the third type of nice enhancement is to make the decision based on not just whether the link is available or not available, but based on the SLA of the link. So in this case, for example, if I have high bandwidth video, I would prefer to send it across the high capacity broadband circuit, as long as that broadband circuit can carry a good performance for my video. But if the performance falls below an SLA, only at that point do I want to put it back onto my private circuit. Those are three good examples of when I would actually be interested in using policy-based steering. So to summarize this section, we've now seen some options for advancing from not the private WAN, not just to hybrid WAN, but to SD-WAN managed, simplified hybrid WAN, to then actually having advanced SD-WAN that can assure performance across all the links. So let me go to the next concept in terms of, we just saw the goal on the transport side. Now let's look at how we can really expand the definition and the capability of a hybrid network. All right, so on the very left arrow is to optimally we want to include hybrid apps and compute as well. Right? It's a hybrid network, so it's not just a transport. It's actually the destination and the business applications. And to leverage a hybrid deployment of actually SD-WAN itself, as well as additional services to really fill out an ideal hybrid network design. So basically, we saw this the high-level target. So let's shoot for the clouds. Let's get the hybrid network to support all my applications, my infrastructure as a service, as well as the SD-WAN itself delivered from the cloud. So let's look at let me go back and look at a historical perspective on legacy hybrid. Right, so the typical setup, as I said, it's an all on-premise solution, whether it's legacy router or in fact even some other SD-WAN solutions. We will add internet to the private circuits to build out a hybrid network from the branch to the data center. but it's not optimized for migration to the cloud. And then the two scenarios are, in this case, if you want to go to the cloud, the traffic is backhauled across this hybrid network, which hopefully has a SD-WAN overlay on it, but you still suffer the performance penalty of backhauling the traffic, and it also congests the WAN bandwidth into the data center. So the next option on the next slide is to address a migration to the cloud, and router solutions do this as well as standard SD-WAN and not advanced SD-WAN solutions by offering a direct breakout to the internet. All right, so obviously for hybrid networks that are now provisioned with a broadband internet circuit, you can enable split tunneling. The SD-WAN can simplify the configuration of sending that traffic destined for the internet and cloud services directly from the branch without backhauling. But the problem here is it bypasses both the private circuit with the SLAs, as well as it bypasses the SD-WAN overlay that is between the branch and the data center, and basically puts it on an unmanaged, best effort internet link straight out, something that Gartner calls spray and pray. So this is not ideal as well. This is where we want to, as I said, move the SD-WAN service not just between the branch and the data center, but to the cloud as well. So obviously, starting with the SD-WAN, obviously, I want to reinforce while we're talking about moving SD-WAN to the cloud, SD-WAN itself can be deployed completely on-premise. This is an absolute option. So you see in this case we have SD-WAN at the branches and SD-WAN head ends at the data center, the orchestration controllers all on-premise. Now, however, with SD-WAN, even with all on-premise, the connection to the cloud can still be improved somewhat, because you can easily send traffic destined for the cloud to more local or regional breakouts, even though you're using on-premise SD-WAN termination points. So this is absolutely a deployable scenario. In many cases, customers would do this and pay for direct private connections from their major regional centers to their selected cloud apps. But in the next slide, I'll show the really going to the full cloud-delivered SD-WAN, where you have both options available. So the optimal deployment is to have all the functionality of an advanced SD-WAN solution, not just from site to site, but extended directly to all apps, including cloud apps or hosted services or infrastructure as a service. So this is done by provisioning the SD-WAN node directly in the cloud, distributed with the cloud apps. To be easy and cost-effective for an enterprise customer, we believe this should be available as a hosted service. To be efficient for service providers to offer this technology should be multi-tenant. It should be virtual and deployable on a different range of platforms, and easily scalable and redundant. So this is I think the promise of hiring cloud-delivered SD-WAN that can extend the hybrid network to both on-prem as well as hybrid compute. To leverage on-premise edges for enterprise apps and leverage cloud gateways for cloud destinations. So as I mentioned before, as hybrid network should encompass the hybrid apps and compute, let's move SD-WAN to the cloud as well. In addition to leveraging SD-WAN in the cloud, the full synergy would come from also leveraging additional services on a hybrid basis, i.e. on-premise as well as in the cloud. So for example, security services. And what SD-WAN can do here is the business policy or abstract framework, one-click service insertion, can actually simplify distributing services that were normally centralized in one single enterprise data center to either regional enterprise on-premise hubs or mix and match with hosted cloud or network provisioned services. So basically, and do this on an application level, so based on recognizing an app, send certain traffic, in this example below, send web email, for data loss protection to on-premise solutions, but that might be further distributed, that SD-WAN makes simple to forward, and then send the rest of web-based traffic to a service provider or cloud-provided security solution. So that would be an ideal deployment. So now let's, in this next section, let's put all this together and look at the various deployment topologies, both for the transport as well as the SD-WAN services for really building out different hybrid WAN networks. So the first one, common topology and a use case for an enterprise, I think you referred to before, is to extend the capacity and the redundancy of a private WAN from the branch to the data center by adding internet, and we're adding it in parallel to create a hybrid network. So from each source to destination or branch to headquarters, we have a parallel use of a private network and internet. An enterprise can deploy this themselves, or a service provider or an MSP can manage this for an enterprise, but it's managed on-premise. So key here is it is not in the SP network, and so basically this overlay is independent of the provider services or circuits. In the top of this one, we show actually that SD-WAN delivered from the cloud to support cloud destinations. And again, this could be deployed by an enterprise as a do-it-yourself in the cloud, but that's rather difficult. A cloud-deployed gateway in the upper side is best procured as a hosted service. So that's the first topology. So the second one, in this next topology, in contrast to a completely parallel hybrid combination of networks, also adds in a sequential combination. So in fact, a portion of this, the SD-WAN could be parallel, and then we have a sequential. So it's really a handoff or an on-ramp from the left-hand side SD-WAN or off-net circuit onto an on-net circuit or the private core. So in this case, we have a off-net handoff from the SD-WAN blue network to the green MPLS private core. Now the access from one to the other can be either through a regional SD-WAN hub that's installed in an enterprise site that also has a connection to the backbone. So that do-it-yourself is not shown in the picture, but that's an option. But really, most efficiently, this should be offered as a managed SD-WAN service gateway by a service provider. So you see that gateway between the SD-WAN and the private core. A typical use case for this is where smaller sites, satellite sites, region need to be connected to the backbone, but they're not directly on the backbone, and they're connected with lower bandwidth and more cost effectively. But for this topology, from a service provider view, this deploying SD-WAN in this manner by the SP, it goes into the service provider network, so it's part of their infrastructure. So it provides terrific value add for the provider and a strategic on-ramp into their core services as well, whether it's the backbone service or actually other network delivered service. And then they can also use the SD-WAN overlay to provide managed connection to any cloud destinations that the enterprise wants to access on the top of this diagram. So a simple extension to this off-net to on-net is a further extension to a regional SD-WAN hybrid technology. So we have multiple often our SD-WAN regions or regional WANs. SD-WAN optimizes the last mile, whether it's hybrid or even pure internet, and these multiple regional WANs are connected via the existing private core. So the primary use case for this is to ensure, for example, long-distance global or international traffic traverses a private network, but to get the benefit of the hybrid WAN and dynamic branch-to-branch for more flexibility of transports within a given region, and yet still have the existing SLA managed backbone connectivity. And then the final topology, incremental migration is a huge benefit. The other on hybrid is to actually have hybrid as in mixed sites. So SD-WAN managed hybrid networks coexist with legacy hybrid network definition that we had earlier. And even within a single site, what we're showing is an SD-WAN can be the only device in that branch, as in the bottom branch, or installed alongside an existing private network router, as in the case of the middle or silver site branch. And then what makes this possible is dynamic routing protocols, centralized orchestration of route preferences across from the SD-WAN to the non-SD-WAN sites simplifies this coexistence. So in the next section, let me then look at how we can layer on additional advanced services. So one of the advanced services I discussed earlier was the assured performance independent of any transport, but there are other advanced services that you can expect from an advanced SD-WAN solution. But first, let me go back to this the concept of the assured performance. So remember we said we have the pole vaulter. We want to shoot for the stars. So an analogy of let's use SD-WAN, but given the height, and I'm afraid of heights, but what I hear from customers is possibly going without SLAs is kind of scary, right? So what gives the pole vaulter the confidence is the safety of this big inflated blue mat. With SD-WAN, we may not have the SLA, right? What gives you the confidence is the proven results that SD-WAN can actually, with the right technology, leverage best effort internet into a hybrid WAN, get good performance. And what we've found, and we've done a huge sample, so multiple millions of samples over hundreds of cities, across hundreds of different providers, is that with the right advanced SD-WAN technology, you can get quality voice performance, and voice is one of the most demanding applications over 99% of the time. I think it was close to 99.5%. And this was actually over only dual broadband. Right? Would be actually higher if one of the circuits was a private circuit in a hybrid network. And this is actually measuring excellent performance. This is not availability. Availability would actually be much higher and close to the same you would get with a fully private circuit. So basically the concept is, while you don't have the overall business SLA with that you have with private circuits where your provider would engineer the performance, really with SD-WAN it's similar. Now the optimization is going across different types of networks and even different providers. Right, so enterprises can do this cross-resource optimization and give themselves the engineered performance. So really pick that instead of depending on the SLA from a single provider. In fact, you can actually engineer a more robust network by engineering with SD-WAN the use of diverse circuits. And for service providers that offer a managed SD-WAN service, they can actually provide an SLA. And now with SD-WAN, they can do it even if they add internet broadband, even if they add off-net circuits from a partner, and even if they allow their end customers to bring their own circuits. That's the promise of SD-WAN, is to get this engineered performance. So moving on to simpler services, we're often asked about, well, if I incorporate internet into a hybrid WAN, is it secure? And basically, all the SD-WAN solutions will achieve this with a standard IPsec encryption end-to-end, or an advanced solution would do this. And in fact, the better benefit is not just having security, but it's actually this level of security is unified. So for simplicity and actually more robust security, because it now goes across all links, even providing this end-to-end encryption over private networks that you may not have encrypted traffic across before. Now it's very simply encrypted end-to-end, so you're guaranteed of the security no matter which link you use in your circuit. Another advanced service, right, available with an advanced or a cloud-delivered SD-WAN solution is to simplify VPN to a hybrid compute environment, so to the cloud as well. So obviously on the bottom, an on-premise hub on the lower right can automate VPN to the data center, as well as enable dynamic branch-to-branch VPN. But now the additional benefit is this automatic VPN. As you add, move, add, change branches, can be extended for the branches to a third-party cloud infrastructure as a service, and do this via the cloud gateway. So now a cloud gateway in the upper part of the diagram can now serve as the aggregation point directly at the distributed cloud data centers, both ends under the management of the SD-WAN orchestration. So I have a simplified VPN setup. I eliminate the manual end-by-end tunnel setup if I'm going to a third-party cloud service. And then an additional interesting advanced service, right? Since again the goal was to I should be on slide 29. In a second, I'm having trouble hitting this slide. I guess the slide is not showing up here, but I'll just talk about it quickly. It's not showing up through this webinar. Sorry, is to have a multi-source inbound QoS. So, since the goal was to eliminate backhauling of traffic from different sources through the single data center, it introduced a new challenge that there was no single point of control. And so now you have a branch that will receive traffic from both their enterprise data center as well as from their cloud applications. And this is where, but we know the application priorities. Each site, the SD-WAN can profile the capacity into each branch. So basically, this is where coordinated orchestration of SD-WAN can deliver an additional service, which is what we call multi-source inbound QoS. We can actually rate limit traffic from multiple sources coordinated at the source. That's a very nice additional function as we enable the direct connection to distributed resources. So onto the final slide. So in summary, what we've challenged you with today is to achieve the highest level of hybrid transport. We want to, on the right-hand axis, move towards the advanced SD-WAN. So from hybrid to simplifying the management to assuring performance across any link and really leverage all the link capacity. As well as to optimize this hybrid network, not just for the transport, but with an eye to the left-hand axis as you're accessing hybrid apps and compute at infrastructure as a service sites, and to do this by leveraging cloud-delivered services in the middle. So by actually moving the on-premise services, enhancing them with SD-WAN, extending the SD-WAN to the cloud, as well as other services. And overall, SD-WAN makes the selection of these very flexible. Right, there are absolute benefits and synergy to match these across. For example, to not only leverage internet for, but also cloud-delivered SD-WAN services. And even if your network only has enterprise apps today, you can still get benefit from the hybrid WAN transport. So this is a great deployment and the summary for where we challenge everyone from enterprises and service providers to get to a full hybrid network vision by deploying advanced SD-WAN solutions and services. So we will wrap up with an advertisement for our next upcoming webinar. So the next deep dive is that we'll explore how SD-WAN is applied to various service chaining requirements at both enterprises and service providers, and that will be on August 17th. So with that, let me turn it back over to the team, and we'll open it up for a Q&A session.
Thank you, Steve. Thanks, everyone, for listening. We have about 10 minutes. I'd like to let everyone go about 10 minutes before the top of the hour. So we'll jump right into the Q&A. If we don't get to your question live, we'll answer via email. So, Steve, early on, the question came in, how does voice traffic deal with the traffic being rerouted?
So the quick answer to that is, again, this is why it's a dual-ended solution. So it is a tunnel between the two ends directly from, so any traffic from one source, while we could place it on different links, different circuits, the tunnel termination will be at the same end on the other side, whether it be an edge in the enterprise or the same gateway somewhere in the provider network. So that will address any issues.
Next up, what's the current adoption rate of Internet instead of MPLS private WAN?
So the interest is, I think, very strong because and we were just at one of the trade shows. The driver for this is a no-brainer. Really, is a very cost-effective ROI, also driven by everyone knows the increasing applications, bandwidth usage, as well as the increasing usage of cloud applications, SaaS, network services that say the internet is an appropriate medium to get to cloud destinations as well. So it's a very high adoption rate, and I believe on our website we have a prior webinar that actually quotes a lot of the analyst numbers on that, but very broad adoption currently and huge interest where we think it'll be the common case in enterprise WANs in the next couple of years.
All right, thank you. Next question. Can you discuss how reliability and quality are guaranteed over Internet?
Absolutely. So that was the thought on the engineered performance. That was really saying, well, you have a service provider provides an SLA on their private circuits because they basically engineer performance within their network. So SD-WAN is basically an overlay that lets you do similar performance engineering, but now it can be done across multiple types of circuits. It could even be done across multiple providers. You know, obviously, if an enterprise does that across multiple providers, then the enterprise is really engineering it themselves and creating their own SLA. But a lot of enterprises recognize the benefits and realities of that. For example, that instead of just expanding the bandwidth on a single circuit that might have an SLA, even though they add a second circuit, that is actually even best effort internet by actually having two circuits. The availability percentages increase because they've diversified the physical type of circuit, the provider, but obviously they don't get, unless that comes from the same provider, they may not get a business SLA on that. But what proves out the fact that SD-WAN technology can do this is that for providers that use SD-WAN to cover multiple types of circuits from themselves, or as I mentioned, even from off-net business partners, and even when they let their end customers bring their own circuits, they have confidence enough in the technology that we have seen different providers actually extend their SLAs to incorporate these different types of circuits, including off-net circuits.
All right, thank you, Steve. Next question is, how would you start so you're not ripping and replacing existing hardware investments?
Good question. Anything that gets to that, to the concept of hybrid from the point of view of having a hybrid legacy plus SD-WAN overlay, and that's obviously one of the key goals of SD-WAN is to have an incremental overlay deployment, and the fact that it's designed as an overlay allows that. So we can, and then if you actually use a cloud-delivered SD-WAN, you even have the ultimate benefit that you can migrate a single branch to SD-WAN. You can avoid the large CapEx investment on the head end and actually leverage a slice of a hosted SD-WAN service from the different providers out there, including Velo Cloud Networks. And then even within a single branch, as I mentioned, you can deploy an SD-WAN node alongside legacy equipment, and then use dynamic routing to selectively start to move traffic into the overlay. Obviously, the recommendation is to move all the traffic into the overlay so you can have the benefit of the simplified overlay flow control over all traffic. But very flexible options for incrementally migrating on a network basis and even on a single site basis.
Next question. Do you run into packet sequencing issues when using two WAN connections such as Internet and MPLS VPN?
No, so that is one of the core technologies, and that's why for this technology to really deliver its benefit, it has to be a dual-ended solution. So if you only had a single-ended solution and you tried to use different links, then you would have an issue. But because it is a dual-ended solution, that's one of the things that we engineer very carefully in terms of the sequencing, which is why then it was very important to get the full benefit, for example, to a hybrid cloud compute, is that you had to have the other end available as a cloud gateway in front of that, so I can extend this dual-ended technology to all destinations. Whereas other non-cloud enabled solutions, when they had to take traffic not between two SD-WAN nodes, then when it goes onto the internet or broadband circuit, then it becomes best effort because you don't have the ability to apply the resequencing technology on the other side. So you can't really leverage the two circuits sufficiently.
So we have quite a few questions coming in. Everyone, please do continue to send them in, and we'll try to get them to them live. Here's a question. Is there any integration with provider QoS?
So one of the features that you should look for is basically all right. So now assuming QoS on the local side, but in terms of the circuit, so both in terms of the monitoring of the link performance, as well as preserving the markings, an advanced SD-WAN solution can work with the class of service markings on an MPLS provided network. So we can both put the desired markings on so the service provider can see it and provide the COS that is agreed upon, as well as also carry those markings internally. So when the traffic pops out of the SD-WAN overlay tunnel, the legacy network on the other side can also see the transmitted class of service markings. So yes, it interoperates with the service provider COS services.
What kind of integration is there with WAN optimization technologies?
So where we see the deployment of that is typically most of the SD-WAN solutions are focused on the newer optimization for leveraging internet, broadband, and hybrid. The approach that SD-WAN vendors take, including VeloCloud, is to enable virtual services deployment. So actually, in two ways, both having an SD-WAN node be capable of supporting legacy services as virtual services, and then the other incarnation is to actually have the SD-WAN node or edge point available as a VNF itself. And what you'll see is that then the service providers will take both an SD-WAN virtual network function and package that alongside legacy traditional WAN op VNF and offer those as mix and match services on different provider delivered CPEs.
All right, so we have time for one more question. This one is sort of two questions in one. How would SD-WAN at the site connect to MPLS routers is the first part, and the second, are route tables used and shared between MPLS and SD-WAN?
Right. So connect the. I think I showed it in one of the diagrams. So there would be a connection, right, either directly or from the SD-WAN device to an existing MPLS SP router, or could go through a layer 3 switch, and then the traffic attraction or insertion would be you could use static routing, but also obviously recommended is dynamic routing to select what traffic is forwarded into the SD-WAN overlay or returned back to the MPLS router for putting across the legacy network, as well as for redundancy in that site. So absolutely is one of the deployment options. Having an SD-WAN edge device side by side with a legacy MPLS router.
Thank you, Steve. Let's squeeze in one more question. It is, can we deploy SD-WAN without a hybrid architecture?
Yes, no, absolutely. So, and I'm assuming that means you can deploy SD-WAN. So obviously, on a single link, and the single link could be single broadband. It could be without hybrid from the point of view of just public circuits, so multiple public broadband circuits. You can also deploy it across just a private circuit as well. But obviously, the biggest benefit is from deploying it across multiple circuits and using the SD-WAN technology to actually unify and consolidate the usage of multiple different types of circuits, which is the key goal of a lot of enterprises and businesses.
All right, I think we're ready to wrap up. I'd like to thank everyone for listening and participating, and I'd like to thank Steve for presenting. And again, remind everyone that on August 17th, Steve will continue the discussion on SD-WAN architectures, and we'll tackle service chaining. And with that, thank you very much, and have a great day.
Thank you, everyone.